saints in lockstep.
Hello and welcome to the practice problems video on the section on points on circles using sine and cosine. Okay, so here's number 1. We have the point P is on the unit circle. If the y-coordinate of P is 3 over 5 and P is in quadrant 2, find the x-coordinate. Okay, so let's draw some pictures. So we have a circle, right? So let's say this is the unit circle, meaning it has a radius of 1. Okay, and it says we're in the second quadrant, so over here somewhere, and it says the y-coordinate is 3 over 5, okay, so maybe it's somewhere here or something like that. Okay, so we can draw a line straight down and make a triangle. So let me just blow up that triangle a little bit. So we have a hypotenuse of 1, because our radius is 1 all the way around. We have some angle here, okay, and then we have that our y-coordinate, so here's y and here's x, right, and because we're on the unit circle, we can say that y is the same thing as saying r, which is 1, times cosine, so cosine theta, and sine theta, okay, because we're on the unit circle and our radius is 1, okay? So whatever y is, that's what our sine is. So if y is equal to 3 over 5, that also means that sine of theta is equal to 3 over 5 as well, okay? So we can figure this out by using a couple different ways. We can use our triangle geometry to do that, or we could also use the Pythagorean identity, and that's what I'll do in this problem, is use that. So if we know sine, we can figure out cosine, and that's what we're going to do. So cosine squared theta plus sine is 3 over 5 squared is equal to 1. So then our cosine squared theta is equal to 1 minus whatever that was, so 9 over 25 in this case. So that's equal to 25 minus 9 over 25, which gives us a 16 over 25, which is nice there. And so now we're at cosine squared theta is equal to 16 over 25. So if we square root, we get cosine theta is equal to plus or minus 4 over 5. And in this case, our cosine is going to be negative because our x value is negative, right? Because we're in the quadrant number 2. So that means our cosine theta is going to end up being a negative 4 over 5. Alrighty, number 2 asks us to find the reference angle and which quadrant the angle lies in. And then we're going to compute sine and cosine of the angle. So the first thing is that reference angle, so what does that mean? So I'll just define it here at the bottom. Reference angle is basically tells you the angle, and this is the symbol for angle that is closest to the horizontal axis, And you'll see what I mean when I draw out some pictures here. So let's start with part A. We have 5 pi over 4. So let me draw a little circle here. So we have that. And let's move by pi over 4. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4 is down here. So here's 5 pi over 4. So our reference angle would be this thing going from this line back to the closest horizontal axis, so it would be right here. So our reference angle is just going to be a simple pi over 4. So pi over 4 is reference angle. And we basically use that because we're trying to reduce our angles down to kind of like working in the first quadrant, because your reference angle is always going to be in between 0 and 90 degrees, or 0 and pi over 2, because you're always going to be within a quarter of a circle away from your nearest horizontal axis. Okay, so in doing that, we're going to compute the sine and cosine of the angle. So basically, when we look at this, we're going to kind of consider pi over 4, and then we can assign values, or like signs, positive or negative signs to those values, depending on which quadrant we're in. So in this case, we're in quadrant 3, so we'll consider that at the end, okay? So if we were to find, let's say, sine of pi over 4 of our reference angle, we would get square root of 2 over 2. And cosine of pi over 4 is also equal to square root of 2 over 2. So our point, our sine and cosine, so let's say sine of 5 pi over 4 is going to have the same values, so square root of 2 over 2, except for it might be negative or it might be not, okay? So in this case, because we're in quadrant 3, both x and y, so both cosine and sine are negative, so we're going to have negative signs in front of both of those, okay? So negative square root 2 over 2 for both sine and cosine there. Alrighty? So now for part B, let's try that again, that same process there. So now we have 5 pi over 3. So now we're going to count by, we can count by pi over 3. That would just give you 2, well, okay, yeah, we can count by pi over 3. So pi over 3 is like 60 degrees. So that's like saying 2/3 of a quarter, which is kind of strange. But that's just saying like, you have, yeah, and basically 2/3 of a quarter. So this is 1 pi over 3. 2 pi over 3 is here. 3 pi over 3. 4 pi over 3, and 5 pi over 3 is right there. So 5 pi over 3 is right here. And the closest that we get to any horizontal axis is actually, we're pi over 3 away from 2 pi, right? So our reference angle is going to be pi over 3. Okay, so if we consider pi over 3, that's like 60 degrees, right? So our cosine of pi over 3 is equal to 1/2. Our sine of pi over 3 was equal to the bigger one, so that would be radical 3 over 2. Okay, so now if we consider our angle, cosine 5 pi over 3, it's just going to differ by signs, right? So we're in the 4th quadrant, which means that x, or cosine, is positive, so we have this positive 1/2. But our sine, our y value, is going to be negative. So we're just going to stick a negative sign in front of that guy, okay?
Oh.